All right, good morning, e-learners.
Who's on the
Well, nobody right now, but I just literally just turned it on. All right, get out your homework. Homework. Get it out. Good job, Julie, whatever you're doing.
Sir?
Well, any kid up, Sarah's on.
Hey, hi, Sarah.
Love you.
That's my wife.
That's my.
No, that's my wife.
Okay.
We're not married.
I know
She gave me, she proposed with a ring.
Wait.
Whoa. What flavor?
I think it was cherry.
Well, okay, well, that'll get it. All right.
What?
We're talking about how you proposed to me.
Oh yeah. Even though like we got married like 1 year before, but that's okay.
All right. Before people question whether or not this is an algebra class, I better do some algebra.
Okay, so do you have a pencil I can use?
No, but I have one you can have.
Oh, you're so.
Only if you tuck your shirt in.
Now that's hard.
All right. Questions on the homework.
Questions on the homework.
I don't know.
Wrong class. That was not homework. Wrong class, bud. Thank you.
What?
That's wrong homework, right? I mean, I wish it was that homework. It looks easy.
I thought I pulled up Algebra 1.
No. Yes. Wait. No. Yes. No.
4, 2, 5. This is right.
It looks like.
We did 2.4.
No, I think I know what happened.
Are you on the wrong lesson?
No, I'm on the right lesson, but I think I know what I did wrong. Give me a second. Homework was what?
2.4, 2 through 36 evens. Yeah, way too many folders.
Well, that's the problem with teaching so many.
Jeez.
Crap. How do you find anything?
Because they're in folders.
How do you find the folders?
Well, they're all done by year and by course name.
The folders are within the folders.
Right.
Subfolder.
Yeah. All right. How about now? Is that better?
Yes.
All right. All right. Let's get back to work here. Sorry for the delay. Questions on the homework? Let's grade this. All right. Let's settle down. All right, here we go. It was 2 to 36 evens. 2 to 36 evens. Number 2 is? Negative 127. Number 4 is 96. Number 6 is negative 16. Number 8 is negative 11.8. Number 10 is negative 11. Number 12 is 5.5. Number 14 is 26. Number 16 is negative 18. Number 18 is 260. Number 20 is 238. Number 22 is negative 21. Number 24 is 4. Number 26 is negative 230. Number 28 is negative 24. Aiden, did you do your homework? Okay. 30 is 0. 32 is negative 32. All right, 34, 36 were tough. You got these good on you. 34 is negative 2. And 36 is negative 143. Those were tough.
Easy.
All right, count up how many you got wrong, put it on the top.
What was 16?
Negative 18.
What was 18? Wait, why was it negative 18?
It was 15 less than negative 3. So how do you write 15 less minus 15? And it says you're starting at negative 3. So same signs, add.
I got confused.
Thank you, boys.
Do we have homework today?
Oh, absolutely.
Why? That's like weird. People do.
All right, everybody look at the board. This one's different. So basically what we're doing is distributive property today. Now the distributive property, in my mind, would have a whole section just to itself. The book breaks it up into 2 sections. I don't know why, but whatever this is, section 2.5, and the next one's 2.6, they distribute, no pun intended, they distribute the distributive property into those 2 sections. So I'm only going to do 2.5a, 2.5b, but I'm going to combine both lessons, meaning like I'm going to use the problems from section 2.5 and 2.6. So you're going to have to flip around. Just copy down what it says. You go to page 68, you do 25 to 36 all, and then you flip to page 72. This is actually section 2.6. And you do 19 through 24 all. This is period 5. This is period 5. Okay? And then tomorrow when we do 2.5b, we'll do the same thing over again. If I were writing the book, I would have written a slightly different, but I didn't write the book.
So we have to do all of that?
You have to do all that. It's not that much.
25?
It's also just the distributive property. If you are already experts because of pre-algebra on the distributive property, please don't talk over me. If you're already experts on distributive property, I will teach you nothing today. Okay? Yeah, remember the first couple chapters are, I mean, even in the next chapter when we do solving equations, until we get to the really complicated ones, it's mostly review. It's mostly review. Now, I know that not all of you are experts on distributive property.
I kind of suck at this.
We're doing the distributive property in course 1. So the book introduces you to the distributive property. Course 1, you never do anything with variables. Course 2, you get the formal class on distributive property. And then in Algebra 1, you use the distributive property. So even though today I will teach you, today it's technically a review, you should have mastered this in course 2 last year. We okay? All right. What? Let's see if what you said is true or not when we do a couple. I'll come back to that. We'll see if it's true. So, big thing, we're just doing the distributive property, where we are going to do it with variables eventually. We're going to start off with just numbers, just so that we're comfortable, we can see how this works. Okay, so the distributive property is a method to help us simplify problems that involve parentheses and multiplication. So whenever you have parentheses and multiplication and a combination of numbers and variables, we're going to be using the distributive property. So for instance, this one right here, if I ask you to simplify that, well, you only have one choice, distributive property. I can't use PEMDAS, right? I can't do 4 minus 3x. There's no answer to that, right? I don't know what x is, so I can't do 4 minus 3x. So whenever you have a number right next to an open parenthesis symbol, like there's no plus or minus right here, you have to use this thing called the distributive property. All right. Some magic happens. The magic is the distributive property. If you already know what the magic is, then you know where I got that from. And then notice you can combine some like terms, and we get into a smaller. So clearly this is physically smaller. I mean, the size. It's only 2 numbers when it used to be 1, 2, 3, 4 numbers. So I turned 4 numbers into just 2 numbers in a variable. So this is clearly simpler than that mess over there. How many people right now could have done this one without any explanation? Okay? It should be a bunch of you. We did do nothing complicated like that last year, but this is what this is Algebra 1. Okay, so box 1. This box yellow. Okay. First off, we've got to identify when to use the distributive property. So this is the when to use distributive property. If you have something on the outside of parentheses, now this is not a math word, but look, there's no space here. It goes A, open parentheses. There's no space between the A and the opening of the parentheses. They're squeezed next to each other. That's the distributive property. Okay? There is no space right there. You're not going to see that in a math book. I made that up. When it's not the distributive property, there will be something here where this blue arrow is pointing to. There'll be a plus or a minus. That means add or subtract. When there's not a plus or a minus, that means multiply. Okay? So the first thing is, and the first mistake I'll see students, they'll do the distributive property when it's addition or subtraction. The only time you're going to use addition or subtraction is when there's a plus right here, or a minus. Okay? So that means multiplication. Just like this means multiplication. Once again, notice there is no space between the 2 and the open parenthesis. There's no plus, there's no minus. Okay? Oh, wait, there's a minus, but where's the minus? The minus is not between the 2 and the open parentheses. It's after the open. This is 2 times negative 3. Okay? So that was the first box. Right? So we've identified when to use the distributive property. Check this out. Distributive property, yes or no?
No.
This one's a no. This means A plus whatever B plus C is.
So it's only when one space was.
It's only when there is no space. When this A is squeezed right up next to the open parentheses, that's when we'll use this thing called the distributive property. Okay? So I guess we call that space. I don't know. Like I said, you're not going to see space, no space in the math book. Okay? So no distributive property there. That's just addition. Okay. Distributive property. Oh, what is that? Distributive property, yes or no?
Yes.
So this is what you didn't see last year. Last year, whenever you had the distributive property, this A was on this
Would
side.
it just be the same thing?
This is the same thing. They put the AO now on the right side. Notice there's no space between the closed parentheses and the A. So once again, this is the distributive property again. This is new for this year. You did not see that last year. Okay? So no space again. Distributive property. Distributive property, yes or no?
Yes.
Yeah, there's no space here. This means A times whatever B minus C is. Okay, no space. Distributive property, yes or no?
Yes.
Well, it's got a minus sign right here, but it's not between the A and the open parentheses. So this, once again, is distributive. You did not see this last year. They always made the first one positive. They might have had a minus sign here. The first one was always a positive number. Now you're going to have a minus sign, a negative number right here, or a negative variable in this case. Distributive property, yes or no?
Yes.
Last year, the thing in front of the parentheses was always positive. Now guess what? It's going to be negative at times, a lot. So this time, we're going to have to distribute a negative number or variable to the inside. Now, why it works. Why does the distributive property work? Well, obviously, we could use what to get to an answer here?
You could just do
We could just use PEMDAS. So let's
Be
see.
easier.
4 plus 2 is,
6.
and 6 times 3 is,
18.
6 times 3?
I said 18.
I didn't hear you, sorry. 18. She's looking at me like I said it, right? 18. Now, the distributive property for those, most of you you should all have been exposed to this. The distributive property says this: take the 3 and give it to everything on the inside. I'm distributing it. If I'm standing there with papers and you're walking in, here's one for you, here's one, I'm distributing it. So you give this is the paper, to everything on the inside. How many things on the inside?
Everything.
How many things on the inside? Right now, how many things are on the inside?
2.
There's 2. There's a 4 and a positive 2. So I give this 3 through multiplication to the 4. Right? This is the distributive. New kids, did your math teacher last year make you draw arrows for the distributive property?
Yes.
Yeah. So draw arrows. Draw it. Because what it does is it tells you what you need to multiply.
Do we have to?
I need to do 3 times 4, which is 3 times 4 is
12.
12. Plus 3 times
6.
2,
6.
which is 6. So I get what? 12 plus 6, which is 18. Hold your question. She has the right question, but not right now. That's the distributive property. All right. I truly need to hear this. Who's never done this before? Okay. So we will get there. Have faith that you'll get this pretty quickly. All right. The rest of us, we've all had this before. Okay. Or at least you didn't want to admit that you haven't had this before. So the mechanics of the distributive property. Oh, check it out. This answers Josie's question. Josie, why do we have to use the distributive property?
I didn't ask that question.
Yes, you did. She said, wouldn't it be easier to do PEMDAS?
Oh, yeah.
Why do we have to use the distributive property?
Because of variables.
Because I don't know what x plus 2 is. So there's no option here. The previous one, well, I know what 4 plus 2. I could have done PEMDAS. right? But we're done with that, right? We're going to see ones that look like this, where you can't do x plus 2. You must use the distributive property. Here are the mechanics. Sarah, you ready? There are 1, 2 things on the inside. I got an x and a positive 2. I got one thing on the outside, a 3. I'm going to give this 3 to everything through multiplication. Why multiplication? Because it says 3 times whatever's here. We use these arrows to show us what we're multiplying. When there's no space, we need to multiply. We got to use the distributive property. So we draw one arrow. It tells me what I multiply first. This is 3 times, what is 3 times x? 3x, okay? So most kids will not write this. And no, I don't expect you in Algebra 1 to write this. I expect you to write one arrow and write 3x, okay? I'm going to show you this for a couple slides, and I'll stop doing it myself. First arrow, 3 times x is 3x, okay? The second arrow, the red one, is 3 times, what does it say? 3 times?
2.
It doesn't say 3 times 2. What does it say?
3 times plus 2.
It says 3 times positive 2. You're like, well, it's the same thing. Yeah, but pretty soon this is going to be negative, and the x is going to be negative. So you must remember the arrow includes the negatives if there's negatives involved. Hey, the 3 could have been negative 3 on the outside. But it's negative 3 times positive 2. Okay? 3 times 2 is positive 6. Do you need to write this? And the answer is no. Do I want to see arrows? Yes. I don't want you to just draw 2 arrows and then write the answer. I want you to draw 1 arrow and write the answer. 3 times x is, and 3 times positive 2 is positive 6. So we simply write 3x plus 6. The 2 answers are a 3x and a positive 6. Well, I can't add these together, so I'm done. The claim is that this is simpler. It doesn't really look that way, but this is simpler than that. So if I ask you to simplify something with a distributive property, that's what I'm asking. Okay? One more time. This is an Algebra 1. What's on the outside? Without the parentheses, it would look like parentheses minus 7. This is new for this year. With parentheses, you can see it's this thing times this thing. You didn't see this last year. We still only have one thing on the outside, 2 things on the inside. How many arrows do I need? And it doesn't matter which arrow you do first. What do I multiply by? The thing farthest away or the thing closest? It doesn't matter. Whatever floats your boat. But I'm going to do the farthest thing away first. What does this multiplication now say? It says negative 7 times positive 5b. What's negative 7 times 5b? Negative 35b, right? Now, yes, it'd be great if you wrote this, but that's kind of really tough sell for Algebra 1 students because you already know this. You can do that arrow in your head. So if you want to write negative 35b, go for it. Just make sure you're doing the math correctly. Okay, the second arrow, what do we get? Chris, what 2 things am I multiplying with the red arrow? Absolutely not. You said 7 times 4, and I said absolutely not. Sure looks like 7 times 4. If you do it that way the second time around, you'll never make the mistake. The number 1 mistake, and I said it yesterday, is kids drop negatives. You're going to have negatives in almost everything we do from now on. So don't drop your negatives. Chris, a negative times a negative. Okay. Clearly you got that, right? So it'll be the negative 7 times negative 4. Now, once again, I don't expect you guys to write this. I'm just showing you what I'm multiplying. All right, we said negative 7 times positive 5b was what? Negative 35b. And negative 7 times negative 4 is? Somebody?
Huh? 35.
I didn't say it. I said negative 7 times negative 4.
That is 20.
Positive or negative?
Positive.
Which is why I put plus 28. You okay? Stirring your memory from last year of doing this? I mean, we didn't do one look like this last year. All right, one more time. Oh, decimals. Don't panic. How many arrows? 2. First arrow, what am I multiplying? No. That's not a 2. Look at it. 2.1 times. Okay. Second arrow, what am I multiplying? 2.1 times a positive 3. All right, well, that's easy. What's 2.1 times y? 2.1y. What's 2.1 times 3, though? Let me catch up with you. 6.3. Can you guys do this in your head? Be careful. All right. I expect to see arrows. The arrows tell me you know what you're doing. It also allows me to point where you make a silly mistake. Generally, your silly mistakes will be a negative times a positive or a negative times a negative. You'll just forget. Rylan, you with me? All right. You want to do this by yourself? Or you want to do it with me? Want to do it by yourself or with me? What? All right. I'm with you. The rest of you do this. Let's do first. One arrow at a time. What do you get? Second arrow. Which gives you positive or negative. 6 times A is, and 6 times 10 is positive or negative. Positive 6. That's it. You can't do anything. Because it's 6 times A. I don't know what A is. All right, 3 times, and you don't need to write this. 3 times negative 9 is. No. Well, if you want to write the step, you can. I'm just saying most kids skip this and do the math. 3 times negative 9 is. Right, 27. You can see why this is why most kids do 27. Second arrow. Don't go right yet. Just do the second arrow. So this is 3 times. No. 3 times negative is. And that's the answer right there. Now, just be careful. Make sense? Yeah, and it doesn't matter the order you should do it. It should be short arrow first or long arrow. Seven times 3 is. Right, 21. And 7 times negative 8c is a positive or negative, or minus, and whatever 7 times 8 is. Eric, you got this now? Yes? Okay, cool. Call me if you need help. All right, let's go over this real quick. EDH, what you got? First one. Well, do it real quick. You can do this one in your head. Okay? You see what I mean? I said, do this real quick. Do it in your head. Algebra 1 kids, I'm not saying you have to do this in your head. I'm saying Algebra 1 kids are not intimidated by distributive property. The time that you need to be careful is when there are negatives involved. When everything's positive, I usually see no mistakes. Do you need to write this step right here? Like, can you write this step?
Yes.
If it helps you, do it. If it doesn't, you're like, that just seems like extra work. You don't need to do it. I do want to see an arrow, and trust me when I say this. What I would really like for you to do is, don't do what I just did. Just draw 2 arrows, because I don't know, he said draw 2 arrows. Draw 1 arrow, and then write the answer to that 1 arrow. That would give you 6A. Then draw the second arrow, that would give you a positive 60. Force yourself to do it that way, and trust me when I say you'll make fewer mistakes. All right, Aiden, you got the middle one? Keep talking.
And negative 3t.
So negative 27 minus 3t, right? Negative 27 minus 3t. Did anybody write negative 3t minus 27? You could, same answer. Last one, Nathan, what do you got?
I didn't get to it.
Talk me through it. Tell me what to do.
I'm getting 7 times
That's 21.
10, 21.
That would be negative 56c. So take those two together. You said 7 times 3 was, and then 7 times negative 8c is positive or negative? Negative 56c. Okay. Once again, I don't expect most of you to write this step. I'm not saying, hey, you're a bad student. No way. I'm just saying that it's just like pulling teeth to get someone to write this in Algebra 1. In Course 2, pre-algebra, I make them write this so they can visually see it. You get to Algebra 1, just like Sophia just did right there. She just squirts out the answer because you get good at doing a distributive property.
I just needed to see the last answer.
You could have written negative 56c plus 21 as well if you did your arrows in a different order. Everybody with me?
Yep.
All right. Easy, medium, hard. Where are we at?
Easy. Easy.
Okay, don't say easy if you mean medium. Don't say medium if you mean hard. This is something you struggle with as a class. I know. I mean, I teach this enough. Kids don't struggle with this in Algebra 1. The kids that struggle with this are the kids that haven't been exposed to it. So, you know, we got to get this right. So if you need extra help after school, absolutely come see me. Student advisement, call me over. I can give you worksheet after worksheet to get good at this. We're going to use distributive property almost every day in Algebra 1. All right, think about this. Okay, I got parentheses, x plus 2, yes? What's the difference?
Nothing.
Well, yeah, it's got a 1. What's the difference mathematically, though?
Nothing.
Why?
Because anything times 1 is the same as.
Because anything times 1 is itself. So the point here, I remember my algebra teacher, Coach Druckenmiller was his name. 9th grade, Algebra 1, Coach Druckenmiller, you know, he said something to the fact, well, what's the difference between this one? He had a deep voice. And he was like, what's the difference between the two? And we all did the same thing. I distinctly remember that. Point being is this. Does this one have a 1 or does it not have a 1 in front of it?
It does.
It does have a 1. Why don't we put the 1 there? Because it's like saying you guys are 15 to the first power years old. You actually are, or 16 to the first power, right? Or 14 to the first power. You're all one of those 3 right there. We don't put to the first power because it's just extra information.
We wouldn't be.
We also, somebody could be 16 in here.
It's not fair.
I'm 13. Yeah, where did Pepper go?
You're 13.
All right, up here. Sorry for getting you after try. All right, point being is that there really is a 1. And as Josie correctly stated, 1 times anything is itself. So we don't put the 1 there, but there's always a 1 there. Guess what's here, even though it's not there? So there is a 1 between this minus sign and that open parentheses. Why is that important? Because when you have a minus sign, here's the kicker. When you have a minus sign outside of parentheses, it's the distributive property. What are we really distributing to the inside? Yes, it's not a 1, it's a negative 1. So what would be the impact of having a minus sign outside of parentheses? Well, the impact is it's really a -1. Now distribute. Tell me what you get.
Negative x plus -2.
We're not going to put double signs.
Negative x minus 2.
We get negative x minus 2. So the mechanics are this. That 1 is there. When we do the distributive property, that gives me negative x. When we do the second one, that gives me
Minus 2.
-2. So this is what we wind up with. This is what we start. So you tell me, now look up here, what is the impact of having a minus sign on the outside of parentheses?
It just makes it negative.
What do you mean?
Like all the components.
Doesn't make everything negative. Guess what it really does?
Subtraction? It makes a subtraction?
It flips the signs around. Because remember, if this would have been a -2, what would that have turned into?
Positive 2.
So what does a minus sign do to the inside of any parentheses? It flips the signs. I got about 5 people definitely with me. The rest of you are kind of like spacing there. You're going to see this year. You're going to have a minus sign. We'll go back to the original problem. You're going to have a minus sign on the outside of parentheses. You're going to be expected to simplify that. You're like, well, it looks simplified to me. No, you got to distribute the -1 to the inside. Do people really do the distributive property on this one? No, because they know this rule is when the minus sign is on the outside, it flips the signs. It gives you their opposites. Flip is not a math term, but opposites are. Okay, this is a tried and true technique, And you will be using it many times this year. Okay, what's on the outside now? -2. So what am I distributing?
-2.
So what is this negative going to do to every sign on the inside? It's going to flip them. Now we just got to multiply by 2.
60 plus 6.
Okay. So 2 times 3 is 6. 2 times 6 is 12. We already said it's going to flip every sign. So what's the answer?
60 plus 12.
6t plus 12. 6t plus 12. See? It flipped the sign. Instead of being negative, now it's positive. Instead of negative, it's positive. This is because there's a negative on the outside. The 2 obviously doubles everything on the inside because it's multiplication by 2. Yes? You guys seem distracted today.
I'm just hungry.
All right. What is this negative going to do to every sign on the inside? So this is going to be a minus something A. This is going to be a
Negative.
positive something. What is this negative going to do to everything on the inside?
What's the sign?
Well, this one is only being multiplied by 1. It's not going to change any of these numbers. It's going to flip the signs. What's this negative going to do to everything on the inside? Flip it, opposites, and then we got to multiply by 6. All right, do box 3, please. Do box 3, please. Let's do one together. Flip means it goes from negative to positive or positive to negative. First arrow gives you what? Second arrow gives you that.
I just went out of the arrows after the
Negative 10.
Oh,
Positive 20. Negative times negative is a positive.
I tried to help over there.
You think of addition, subtraction. We're doing multiplication.
But because I always put somewhere to be
Negative times a negative is positive.
highlighter.
They're gonna think it's a.
You said it's positive. But a negative 2 times a equals 2. Negative 2a.
Yeah.
Now you just have a negative on the outside.
So from
There is a
Wednesday, Friday,
You're not mine.
I'm here
Negative 1 times positive 9.
ten
Negative 1
half
times.
an hour.
Just all I think is not even alive now. Why not?
So this is why I do just one.
I have lots of things
So
to do.
negative 9. All right, we okay?
Yeah.
Tristan, first one, final answer, go.
I didn't even answer.
Well, let's do it.
So 2a. Negative 2a
Negative 2a.
plus minus plus
What's a negative times a negative?
a negative.
No.
Positive
Positive. Negative times a negative is a positive. So negative 2a,
times plus minus.
you're just saying all those.
I don't know.
So how about we do arrows, right? The blue arrow gives me what?
Negative
2a. Negative 2a. Sorry.
What's the red arrow give me? Don't look at me, look at the board.
Negative 2.
Don't look at me, look at the board.
Negative 2 times. Right?
Stand over here now. You can't.
I'm sorry.
Look at the board, look at the numbers. You're confusing yourself.
Negative 2. I don't know.
When a number is on the outside, does that mean add, subtract, multiply, or divide?
Multiply.
So multiply.
20.
So give me the two things together now.
Yeah, I don't get that either.
Okay. Blue arrow, red arrow. You told me the blue arrow is what?
Negative 2a.
Now give me the red arrow.
20. So negative 2. Not negative 2a plus 20. Hey, you're so smart.
All right.
Yeah.
So getting good at the distributive property, you just got to do it, right? Josie? After you tell me the middle one.
-9 minus 2t.
Yes or no?
Yes.
Said -9 minus 2t, that is correct. Remember, this is a shortcut step. Whenever you see a negative on the outside, all it's going to do is write the opposite. I said write the opposite of what's on the inside. So the opposite of 9 is -9. The opposite of positive 2t is negative 2t. Remember, you're really distributing a -1 to the inside. That's the mechanics. Okay? Get comfortable being able to do that. It's not a shortcut method. It's what it turns into. Who thinks they got the last one? Go ahead, Landon. What do you got?
18 plus 48c.
All these negative, and the whole darn answer is positive. Say it again.
18 plus 48c.
18 plus y, because you're multiplying a negative times a negative both times. That will only result in a positive. So 18 plus 48. Did anybody write 48c plus 18? Because that would be, if you did the red arrow before you did the blue arrow, you get just, it's not the opposite, but you get the numbers reversed. And that's fine. Have I confused anyone? Some of you are going to need some practice, right? Others of you are like, you're already experts at this. So I got to somehow manage the entire class. When we got experts and we got people that need some help. All right. I want you guys to open up your books, get started on your homework, and that'll give myself a chance to walk around. And for the kids that really do need some help, I can give you some help, and the rest of you can get your homework done so that you're not worried about it in period 8. Okay? Nathan, how do you feel? Positive, negative, what?
I did it all wrong if I tried to do this.
I mean, you got the mechanics down, Nathan? Maybe? Maybe I will go give you some help. All right, Sierra, how do you, where are you at this? Good, bad, what? Haley, how about you? Good, bad, or what?
For the homework, for like how it's
Haven't you already turned in the homework?
Who, me?
I did-
One of you, I think, already turned in the homework, didn't you?
I turned in the homework for. I've turned in the homework for the last 3 days.
I know, that's what I'm saying. I knew one of you had worked ahead, I thought.
I think I'm the one who worked ahead.
All right, so Sierra, you said good or not good?
I'm fine. I don't know. I'm really tired right now. I woke up like 5 minutes ago.
Well, luckily for you, we all wish we had woke up 5 minutes ago.
Not good at math. Why is that your name?
Well, I'm coming back next week, so then I'm gonna have to start waking up early anyway.
Yay!
Well, if you're waking up at noon, I think you need a little bit of practice because you have to wake up way before noon to get here on time.
My friends are gonna start waking me up early.
All right. If you guys, either one of you need any help, just send me an email. If not, we'll catch you guys tomorrow.
All right.
All right. See you guys.
Bye.